Students, this session is on topological sorting or topological ordering as well as some definitions on graph. What is topological sorting is, it's a linear ordering of vertices. We have to follow the order UV. It means vertex U come before vertex V. The topological ordering may be one or more than one for a graph. The condition to be followed is the graph should be tagged. It means the graph is directed acyclic graph. What is directed means all edges are with direction, and acyclic means the graph should not contain any cycle. We will see the example with cycle, graph with cycle. So in this example, 0 to 1, 1 to 2, 2 to 3, 3 to 1. So it forms one cycle. Similarly, 2 to 4, 4 to 2, it forms another cycle. So first condition is satisfied for this graph. It means it is connected. All graphs are, so all edges are with the directions. And second condition is not satisfied. Should not contain any cycle. So we cannot calculate topological ordering for this graph. So next, the topological sorting example. First, the graph is taken 1, 2, 3, 4, 5. So the graph is with 5 nodes. And we have to calculate in degree for each node. What is in degree and out degree is, for each node we have to calculate number of edges coming towards the node is in degree. Number of edges going out of the node is called out degree. For node 1, there is no edges is coming towards 1. So its in degree is 0. So we have to calculate only in degree for topological sorting. For node 2, only one incoming node. So in degree is 1. For 3, two edges are coming inside. So its in degree is 2. Similarly for 4, in degree is 2. 5 is in degree 1. We have to start the ordering from node with in degree 0. The first we have to start with in degree 1. Some graph we have more than one node with in degree 0. So we can start with any node, because I said we can have more than one number of topological order for the given graph. So we have to start with 1. After starting with 1, in the down below this slide I will write the topological order with starting node 1. After that I have to remove the edges coming from connected with node 1. So 1 to 2 and 1 to 4 is removed. So remaining graph contains the nodes 2, 4, 3, 5. 2, 4, 3, 5. Again I have to calculate in degree for all the nodes. In degree for node 2 was 0, node 3 is 2, node 4 is 1, node 5 is 1. Again I have to do the same procedure. The ordering start with in degree 0. So I have to start with 2. I put the next node as 2. So far I have 1, 2, the topological order. Now I have to remove the edges from 2. So 2 to 3 and 2 to 4 is removed. Remaining graph contains 3 nodes 4, 3, 5. So I have to calculate in degree for 4, 3, 5. In degree for 4 is 0, 3 is 1, 5 is 1. So it should start with 4. So the ordering is 1, 2, 4. After that I have to remove 4 to 3, 4 to 5 edges. So finally I have 3 and 5 edges with in degree 0. So I have to take either 3 then 5 or 5 then 3. So our topological order for the given graph is 1, 2, 4, 3, 5 or 1, 2, 4, 5, 3. So I can have 2 topological ordering or sorting for the given graph. Next we will see why we cannot calculate the topological ordering for graph with cycle. In this example, 1, 2, 3 to 1, it forms one cycle. So as usual we have to calculate in degree for the given nodes. For 1, the in degree is 1, 2 in degree is 2, 3 in degree is 2, 4, 0, 5, 0. So I can start with either 4 or 5. So here I have started with 4. The topological order I have written 4. Then I remove the edges from 4, 4. The only one edge we have 4 to 2 was removed. The remaining graph is 1, 2, 3, 5. So definitely I have to start with 5. So in this order I write 4, 5. Then the edges from 5 to 3 is removed. Remaining graph I have is 1, 2, 3. So each node is with in degree 1. So as per rule we have to start with in degree 0. That is what we cannot calculate topological order for graph with cycle. Next we'll see some examples on graphs by connectivity. What is biconnectivity is the condition is the graph is the node, all nodes in the graph is connected and it should not contain any articulation point. The first graph it is called biconnected because all nodes are connected. And what is articulation point is, if I remove any vertex from the graph will be disconnected. It means we cannot have connection between the vertices. The first graph, if I remove 0, vertex 0, remaining 1, 2, 4, 3 are in connection. Similarly, if I remove 3, 1, 2, 0, 4 are in connection. And if I remove 4, 1, 2, 0, 3 are in connection. So there is no disconnectivity between the graph. There is no disconnected graph. That is what the first graph is called biconnected graph. The second graph, if I remove node 1, 0 and 2 has no connection. So that is what it is called not biconnected. Next definition is cut vertex. What is cut vertex is, if I remove any vertex from the graph will be disconnected into 2 or more. See the first example, C and E are called cut vertexes. The first graph is a single graph. After removing the vertex E, the graph is disconnected. Similarly, instead of E, if I remove C also, this graph is disconnected. So the C, E vertexes are called cut vertexes for the given graph. And final definition is Euler graph. What is Euler graph is, all vertexes contain even number of edges. See, in the node A, 2 edges are there. B, 2 edges. C, we have 4 edges. E, 2 edges. T, 2 edges. So the graph contains even number of edges is called Euler graph. The assignment for the given session is find the topological order for the given graph. Thank you.